Assalamu alaikum. Hello everyone. My name is Rusmia Sadia and today I'll be presenting my assignment on data analysis using Python. Before starting, the first thing I did was download the Auto CSV dataset which my faculty gave me and upload it in my working environment, which is Google Colab. Without uploading this file, the code would not be able to read the dataset. I have uploaded the file from here. I go to Files. I click Upload. As you can see, I've already uploaded it. This is important to keep my work going in this data analysis. Okay, so in this assignment, what I did was I performed data cleaning, manipulation, analysis, and visualization step by step. Now I'll explain each task clearly. My task one was to download and load the dataset. For this, I first imported the required libraries. Import pandas as PD. This is used for working with data tables. Next, I used import matploit lib.pyplot as PLT. This is used for creating graphs later. Then I wrote df equals to pd.read underscore csv bracket auto.csv, which the file that I uploaded. So this line reads the CSV file and stores it in a data frame called df. In order to see the first 5 rows of the dataset, I use the code df.head. All right, if I wanted to see more rows, I could write df.head bracket 10, then it would show me the first 10 rows instead of 5. If I wanted 15 rows, I would have typed df.15, so it would have showed me the first beginning 15 rows. All right, moving on to my task 2. Here I explained my dataset in a markdown cell. In this step, I explained the dataset, which is the auto dataset contains different car features such as MPG, horsepower, weight, cylinders, and origin, which you will see in the column section. It is commonly used for fuel efficiency analysis and regression modeling, meaning we can predict values like MPG based on other variables. Moving on to task 3, here I was instructed to explore the dataset. So I have used different codes and explored my dataset. At first, you can see for showing the dimension, I have used df.shape. What it does is it gives a tuple like row number and column number. As you can see, the row number is 397 and the column number is 9. This is what exactly dot shape does. All right, next one is len df. This only gives the number of rows, which is 397. We have already discussed the function of head dot head. Df.head gives the beginning first 5 rows. If we use df.tail, it will give us the end of the dataset, that is the last 5 rows of the dataset. Let's say we don't want to see last 5 rows, we want to see the last 20 rows. What do? Then we just type df.tail bracket 20, then we see the last 20 rows. All right, next, in order to know the type of dataset, we have a code called type bracket df. This tells us the data type. Here, of course, it will be data frame. Next, we have df.describe for summary statistics. This gives summary statistics like mean, average, mean for minimum, max for maximum values. Next, we have df.info. This is very important. It shows column names, data types, and missing values. For showing the column names in a list, we use df.columns. It shows how many cars, it shows the list of all column names, mpg, cylinders, displacement, horsepower, weight, acceleration, year, origin name, every column name. All right. Next, frequency table. So for showing frequency table, let's say we have a code here, df, the column I named cylinders dot value counts. What it shows is how many cars belong to each cylinder group. For example, 4 cylinders may have more cars than 8 cylinders. Next, we have for unique values, we have df origin dot unique. So this shows unique values like 1, 2, 3. All right, I have explored my dataset. My next task is handling the missing values. This is an important one. Here I cleaned the horsepower column. For such, I have used df.isNull.sum. It checks my missing values. The next code is PD to numeric, df horsepower, comma errors dot course. It shows it converts values into numbers. So if any value is invalid, like question mark, it becomes NaN. All right. So next we have mean underscore HP equals to df horsepower dot min. This calculates the average horsepower. Filna. Next we have used dot filna mean underscore HP. This part helps replacing missing values with the mean. But you might have a question that why mean? We could have taken the median. So why mean? Because it keeps the data balanced and avoids losing rows. Finally, I checked again to confirm no missing values remain. For verifying that I have no missing values, I have used again .isNull.sum. The output shows that np.int640. It literally means, since there's a 0 here, it literally means that there is no missing values. All right, moving to my task 5. This task has multiple operations. Number 1 is selecting specific columns. I selected columns like mpg, horsepower, weight, and year. This helps focus only on important data instead of the whole data set. So it is quite helpful. Second, we have filtering rows. I filtered data using conditions. For example, cars from 1970 and cars with mpg which are greater than 25. When I write df mpg greater than 25, it means it shows only rows where mpg is greater than 25. For multiple conditions, like we can see here, df mpg is greater than 25, and this AND operator is very important to write multiple conditions. Then we place the rest of our condition, which is df cylinders equals to 4, which means that I have now 2 conditions here. One is for the mpg, which should be greater than 25, and another should be cylinders, which is equal to 4. All right, so 2 conditions at once. Next, we have something called sorting. So sorting by horsepower shows weakest to strongest engines. Sorting by mpg shows most fuel efficient cars. So, an important note here is sorting automatically starts from lowest to highest. But what if we want the rank from highest to lowest? In that case, we have to add an extra code, which is ascending equals to false. When we write ascending equals to false, it will show the code in the descending, the dataset in the descending order. All right, so sorting helps ranking the data. Next, we have creating new columns. I created weight underscore kg, which converts pounds to kilograms. mpg underscore kmpl converts mpg to kilometer per liter. Age of the car, which calculates how old the car is. An example is if year equals to 70, then actual year is 1970. Then age equals to 2025 minus 1970. Okay, next step is recoding the origin column. Originally, number 1 equals to American, 2 equals to European, 3 equals to Japanese. I replaced numbers with names using dot map. Then I converted it into category type, which saves memory and improves analysis. All right, moving to task 6, which is summarize data using group by. As we can see, for grouping the data, I have used group by bracket. Example, df.group by cylinders mpg.min. This means grouping data by cylinders, then calculating average mpg for each group. We also have other examples of group by. So it shows that cars with fewer cylinders usually have higher mpg. All right, moving to task 7, which is string manipulation and summarization. Here I worked with the name column. I split the name and took the first word, brand. Then, for example, the full name is Toyota Corolla, but I only took the first word, which is Toyota. Then I counted how many cars belong to each brand. I noticed some spelling issues like VW, Volkswagen. So I corrected them using a dictionary. This is important because incorrect spelling creates duplicate categories. Finally, I saved the dataset to auto02.csv. I'm going to show you later how I downloaded the edited CSV file as well. Moving to my task 8, which is indexing and slicing. So here we can use three types for indexing. First, I've shown using log. Log uses labels like column names. Let's say we have used df.log 0:5 mpg, horsepower. What does this mean? This means that we only take rows from index 0 to 5, only mpg and horsepower columns. Let's see another example. df.log 10:20 weight year. So it means that we take rows from 10 till 20 only for which columns? Weight and year. All right, so how does log differs from ilog? Let's go down and see. So unlike log uses positions as in numbers. Let's say we have a code df.ilog 5:15. What does it mean? It means that it shows rows from index 5 up to 14. We have seen previously that in log, if there is a starting point and there is an ending point, it shows all the points. But here it shows one less than the ending point. Like if we type 15, it will show up to 14. We can also add columns along with rows. If we go up here, we can see the df.ilog. So the first one is for the rows, the second one is for the column. 10.20, it means showing rows from position 10 till 19. And 2:5, it shows column starting from position 2 till 4. All right. Next, we have direct indexing. Going down, direct indexing. So, example as in df mpg 0. What does it mean? Mpg is the column and 0 is the row index. So, overall, we can say lock means names, iloc means positions, and direct means quick access. Moving on to task 9, which is scatter plot. I created a scatter plot between horsepower and MPG. Each dot represents a car here. X-axis, I placed horsepower along X-axis, and I placed MPG along Y-axis. It shows the scatter plot shows negative relationship between MPG and horsepower, negative or inversely related, which means when horsepower increases, MPG decreases, and vice versa. So powerful cars consume more fuel. For scatter plot, we have used pandas. Not necessarily that only pandas will give the scatter plot. We can also use matplotlib. I've shown it here how using matplotlib I have completed the scatter plot. It also gives the same output. We can also do it using Seaborn or pure matplotlib. All right, last but not the least, that is task 10, our final task, which is box plot. So I created a box plot comparing MPG across cylinders. First, I converted cylinders into a category. You can see the code here. I converted the cylinders into a category. The box plot shows median, spread, and outliers. If we interpret this box plot, it shows that 4-cylinder cars have higher MPG and 8-cylinder cars have lower MPG. So smaller engines, it means that smaller engines are more fuel efficient. In conclusion, I successfully completed all the 10 tasks, including data cleaning, transformation, analysis, and visualization. I also learned how to handle real-world datasets and extract meaningful insights using Python. In the end, I have also shown how I downloaded my edited version of the spreadsheet CSV file at the end using files.download command. All right, that's all from my part. Thank you for watching.